All right, I'm just going to give everyone a little extra time to log in. All right, we'll go ahead and get started. All right, thank you guys so much for joining us today. This is the New York Oracle User Group's regular webinar session, co-hosted by Viscosity North America, an Oracle partner. We're super excited to have you on today. Those of you who are regulars with us, welcome back. If you're new, welcome, welcome. You'll hear from a couple of us before we get started with today's session. Before I hand it over to NYOUG to talk a little bit about what they do and what's coming up, I just want to let you know today's session is live. That means feel free to ask questions, take advantage of the time with our speaker today, and also she'll get to your questions at the end, I should say, if we're on time. And Monica, if you need to go over in time, feel free to. If people need to drop, they will, but they have access to the recording later. So I'm sure they would love to go back and revisit any questions that people have. Also, my colleague, Katie, she's going to talk a little bit about viscosity later. She will email you all as well to let you know when videos are up, and she'll also get you a copy of the slide deck from Monica. And I think that's pretty much it. If you have questions for the speaker, please use the Q&A field. If you've got a logistical question about NYOUG, viscosity, or Zoom, using Zoom, throw that in the chat. All right, so with that, I'm going to hand it over to Coleman from NYOUG.
Thank you, Monica, with the C, for the kind introduction. So the New York Oracle Users Group was formed about almost 40, I think a little bit more than 40 years ago, for the exchange of ideas, assistance, and support among users of the Oracle software products. We're always looking for abstracts. Feel free to go on our website and just dig on the link for the New York Oracle Users Group called Abstracts. And let's get this moving over here. So you can connect with us on Twitter, Meetup, and of course the abstracts I mentioned to you. We're on LinkedIn, Facebook, and our website is nyoug.org, where you'll find connections to all the above. And we are also having a webinar week co-hosted with Viscosity. And if you've received our email blast, you'll be able to sign up for any one of the 4 days or all 4 days, whichever you want, with a wide range of Oracle and Microsoft topics. And I want to thank Viscosity North America for co-hosting this series of webinars with New York Oracle Users Group. This has been going on for a little over 2 years right now, and we see no stop in the forecast. We continue to do so. Thank you.
All righty, so it looks like we're getting our slides set up here. Thank you so much, Coleman. Good afternoon, everyone. Thanks again for joining us today. My name is Katie Barnes, account manager at Viscosity. Before we get started with the presentation, I just wanted to briefly introduce you guys to Viscosity and give you some information about who we are and what we do. Viscosity is an Oracle partner. We work very closely with Oracle Product Management, and we now have 6 Oracle ACEs on our team. Many Oracle customers are increasingly relying on professional service partners like ourselves to serve as trusted advisors and to help make better purchasing decisions. Our business model at Viscosity is very simple. We work very hard to build trusted relationships, and we implement technologies and solutions when the time is right. We're always happy to be a resource to you, whether that be tomorrow, next year, or later down the road. So this slide shows our areas of expertise, which fall under 3 pillars: data, apps, and infrastructure. A large bulk of our business is on the database side, including data integration, data warehousing, zero downtime migration to latest versions, and overall we help improve performance at the database level. In our applications practice, we do a lot of Apex development, EPM, ERP. We also develop custom apps. And lastly, our infrastructure and hardware practice includes Oracle's public cloud offering, bare metal engineered systems. We were actually named Oracle's ODA Partner of the Year back in 2019. So as you can see, we're very active within the Oracle community. We do pretty much everything when it comes to Oracle, but these are some of our more broadened areas of expertise. The people that you see here on this slide represent some of our leaders at Viscosity and our lovely Oracle Aces. We have 6 Oracle Aces now. These guys are amazing. They are frequently presenting webinars for us and at user group conferences around the globe. They are all wonderful leaders to have within your network and are eager to meet with individuals like yourself. Here are some of our other services that we offer. We have experts in Oracle license management that have actually come from Oracle and have worked in that space for several years. We provide all of our customers with knowledge and best practices on how to manage and maximize your Oracle investment. We are probably most known for our zero downtime migrations and upgrade services. We've helped customers migrate from AIX to Linux with zero downtime, and more recently have been helping our customers with upgrading to Oracle 19c. Our performance health checks allows us to fix pain points before they become real problems for our customers. And lastly, we also offer a full stack of DBA services as well. I wanted to include this slide to showcase the work that Viscosity has put into becoming trusted advisors who have actually written the books on Oracle's latest technologies and versions, anything from virtualization, pluggable databases to Oracle Exadata. We offer consulting and strategy meetings to assess any of your current projects, pain points, or team goals, and to share our resources with you like the books that you see here. So if you are available to connect with us, please shoot me an email and we'll schedule a time to connect. As of the first of the year, Viscosity has acquired Orapub, one of the leading Oracle training companies in the US, founded by Oracle ACE Director Craig Shallyhammer. Craig is now a part of Team Viscosity, and together we provide both predictive analytics and performance tuning training for Oracle systems. Now that Orapub is powered by Viscosity, it will continue to be a one-stop location for specialized training in machine learning and Oracle database performance tuning. Orapub and Viscosity alike are designed to help Oracle professionals get the answer and skills that they need through engaging training and useful resources. All Viscosity hosted webinars can be found at www.orapub.com with recordings and slide decks. You can sign up for a free membership to reap the benefits from webinars like today's presentations, workshops, or quick tips, or you can also purchase a membership tier for access to even more content and resources. Just a quick reminder, I will be sending out an email to everyone tomorrow with instructions on how to register for an Orapub membership, where you can access today's presentation materials. And last slide before I hand it back to Coleman to introduce today's speaker. If you haven't already checked out our events page, please do so using the URL that you see here. The URL to our events page has changed recently, so make sure you have the updated URL. It is now event.viscosityna.com. We update this page on a monthly basis with all of our webinars, workshops, other great events that we have going on, and it's a really great resource. Another reminder, we'll have this presentation posted on Orapub as well as the NYOUG.org website with so many other great resources. Just another quick reminder, this is a live presentation, so if you do have any questions, please submit them using the Q&A box, not the chat box. And with that being said, thank you so much for listening. I'll go ahead and pass it back over to Coleman so we can introduce today's speaker. Thank you.
Thank you, Katie. So Monica with a K is an experienced Oracle architect, designer, and developer. She started her journey with Oracle in the last century with Oracle Database 7, continuing to this day. She emphasizes the solution's simplicity, code quality, best practices, and above all, system performance. She is an Oracle ace and willingly shares her experience. She loves, get this, fast motorcycles and databases. Thank you, Monica. Thank you, Viscosity, for co-hosting this series of webinars. And Monica, we welcome you to the webinar today.
Thank you for the nice introduction. So maybe I start with sharing my screen. Yes. Okay,
Looks
so it's fine. It's okay. So thank you for coming to my session. Today I would like to share with you an exciting story about my once in a lifetime experience. A couple of years ago, I had the opportunity to be a technical leader in the back office system reengineering project, and I could see with my eyes how our changes affected the quality and the performance of the application. Because at the end of the project, we have two systems, database Oracle systems, which were running in parallel. So we could in a half a year. so we could compare the effects of our work. So let's see how it went. My name is Monika Lewandowska. I'm ORAC designer and developer, and ORAC is not also only my work, but also a passion. And my other passion, and Coleman said, is riding by motorcycles, especially traveling. And this photo was taken in Georgia. And well, I couldn't really move. And my husband, instead of helping me, he was taking the photo. So yeah, but it's just for fun. Maybe this is the moment I should assure you that I think I am a little bit better with ORAC than with riding. But if you are interested in my adventures, ORAC on motorcycles, you can visit one of my blogs, How to ORA or NA200 blogs.com. So let's start. First, I would like to ask you, how long do you think should take closing a day in the system? So based on the name, it should take less than a day, I think. But record I've seen was 23 hours to do those processing, night processing, end of the day processing. So yes, it's less than a day, but I think it's much too long. But what the heck is the back office system closing a day? What I mean by that? What I mean by back office system is the system which has some inputs. So it could be data, everything we need to run our business. So we can load to our database data manually from the front ends, websites, etc., from the files, or we can load data from the other systems, of course. Then during, we have to do some calculations, some database magic, and prepare some output. What output could be? Anything we need. So maybe some fees, interests, commissions, invoices, statements, everything. And our processes are everything are based on our input data, and we convert them, we calc something, fees, interest, anything, just to have some output here. We can present our output, our data to users on the websites. So we can create some reports, files, or our output can be input to other systems, of course. So how long we need to do this to prepare those outputs? How much time we have to do this? Usually we base on the data which are loaded to our system. So usually we have to wait till users or other processes stop working, and when we are sure that everything we need to do the processing. And what is more, our processes usually are very heavy, so it's not very reasonable to do them during the daily routines when users are working, because it's too heavy and our system could be very slow when we do those processes. So mainly we can start when our users stop their daily routines, when they are at home resting. And this is, well, at the evening when they are home. And of course, we have to finish our processes before they start the next day. And what is more, usually, sometimes we have something called SLA. So this is service level agreement, where we agreed with clients that we deliver the reports, the outputs before the specific time. And if not, this may result in some penalties, sometimes heavy penalties, depends on the client. So we have stopped before the specific time. So we usually have the night, couple of hours, 10 hours, 12 hours to finish our processes. But if our standard process takes 10, 12 hours, if any problem occurs, then it can enlarge the processing time and we can easily exceed the deadline. So, well, the answer is the shorter the better. So if our process, we can finish it within 1 hour or 2, we have many more hours to fix any error occurred in the system. For example, performance issues or other kind of error. So yes, the shorter the better, of course. Before I start talking about this project, I want to introduce some definition which we used in this project. This will help me explain the differences in handling data in our system. What we did was divide our data in tables in different categories, depending on data they store. For example, first category was configuration data. We all know what is this. This is configuration, parameterization, anything we have to say how our system have to work. This data usually stored in the small tables and data are changed rarely, very rarely. Another category, the most important, I think, it's main data. I call it main data, business data. It's everything about what is crucial in our business. For example, if we have bank system, it could be our bank accounts, clients, card holders, card numbers, etc. If we have insurance system, this may be clients, policies, etc. So this is the main data in our system. These tables are medium-sized, but volume of data grows very, very fast because, I'm sorry, not this one. Data volume are quite stable because we can gain new clients, but we can lose some clients too at the same moment. So maybe these tables are growing, but not very fast. And third category, I call it events. Events is every action on our made by our main data, made by our clients, or everything which affects our main data, usually from financial point of view. So it can be card transactions, some fees, interests, phone numbers if we have a mobile phone system, etc. So these events tables are one of the biggest in the system because our clients continuously doing their actions. So clients pay by cards, people are doing phone calls every day. So data are growing very, very fast, but are not changed a lot because if we did some phone call, we did it, nothing to change. And the last category, logs, of course, these are the biggest tables in the system, stored historical and archive data, system errors, some warnings, volume data are growing very, very fast, but shouldn't be changed. If you change those data, you probably have a performance issue or you will have some soon, very soon. So this is definitions and I want to give you some details about the system because I'm not allowed to talk in much details, of course, but I want to bring the system a little bit closer to you to let you imagine what kind of system I will be talking about, if it is a very small system, 2 packages and 5 tables or something bigger. So we have 100,000 lines of code, 100 tables, about 100 packages, 3 million and clients and 5 million products. So our main data were something 8-10 millions of rows. We had events, 1 million events every day. So during 1 month, we had 30 millions of events information, events data. And during the night processes, we have 20 separate different processes. such as calculation of interest, fees, checking the limits, some overdues, maybe creating the generating the invoices, some statements, etc. So this is 20 processes, and our processing time was 8 to 10 hours. It depended on the day of the week and on the day of the month, because the biggest processings were on Mondays and the last day of the month. So if we have the last day of the month on Monday, we already knew that we'll be late with our SLA, and we didn't manage to deliver the reports and data to our clients on time. So our system was getting old. Usually new systems are quite fast because they have new indexes, small tables, not many data, little historical data. But after some time, maybe a year, maybe half a year, performance begins to decline. And this is what we had in our system. Our standard processing time was 10 hours. So every single problem enlarged and we exceed the deadlines. We every day struggled to tune the system, to optimize this. Administrators that DBAs try to do, DBA's magic and did something with disk memories, parameters, database parameters, etc. We, as a team, tuned SQLs or single procedures, try to fix the performance issue, which were day by day occurred in our system. But every our tuning action helped only for a short time, because if you tune one procedure, it occurred that at the other end of the system, another procedure has had the problem. So we had to start to tune the other procedure. So it was something like a loop, never-ending story. We had also a large number of errors due to the high complexity of the system, and because we had still tune SQLs and procedures and some errors. So it end with a large number of errors. And thanks to that, we spent most of our time on maintenance instead of development. And what is more, thanks to the high complexity of the system, we have very high modification costs, and even small new feature took 2 weeks, 3 weeks to develop it. And what is more, every new functionality enlarged the processing time. So we had to fix the problems, performance problems at the same time when we try to develop something new. So we were really tired to tune it all the time. And because our normal activities, our normal optimization were no longer effective and our efforts were, well, useless, we decided that we have to do something more, and we had to fix all the problem as a whole, not only in points, single procedures and SQLs. So we could do this all or by buying new system from the market, or by doing big project, engineering project. Of course, we are developers, so we desperately wanted to do this project. So we had to convince our bosses, how to convince the bosses to make them spend a lot of money for our project. So we had to convince them that their money will not be wasted, and that we exactly know what we want to do and how. So we prepared a plan. First, we wanted to do some performance analysis, because, as I said, we tuned almost every single SQL in our system, almost every single procedure in the system. but the performance problem were still here. So we wanted to know where the real problem is, why this performance is so bad. Then we wanted to do reverse engineering, so do some code analysis and write down the requirements based on our source code, because we wanted to be, we had to be sure that our new system will be exactly same as the old one. We cannot lose any functionality. Of course, I bet many of you want to ask if we didn't have any documentation, specification, requirements, and so on. Of course, we had, and you have some tools, I believe, but are you sure that this specification, documentation, requirements documentation is up to date and as detailed as needed to such a big project? We weren't sure, so we wanted to do this reverse engineering. Then, based on this engineering, we wanted to do some analysis to find out if there are any places that can be optimized at the requirement stage. So maybe some requirements are not to date or not needed anymore. And what is more, we did it in cooperation with business analysts. And this is the most important, because we wanted to involve those analysts to this project, because they were important for the decision if we can start this project. Based on this analysis, we could maybe some redesign is necessary, we'll see. And the most fun part of this project called refactoring. And of course, we had a plan here too. We wanted to, we knew what we want to do and how. So we prepared some coding standards and some best practices, and about some of them I will be talking today, and I'll show you some of them. And we wanted to take advantage and prepare unit tests for every single program unit in our system to be sure that the system is in high quality and error-free, of course. And of course, we prepared also a test plan, how to test and compare old and new system to prove that the new one is exactly the same as the old one. So we have the same output. As I said, we have two systems, old and new, work in parallel for about half a year. And we prepared some tools to compare outputs and reports and check some data to compare data. So we prepared some tools for this comparison to find out if this is the output is the same and the data are the same. And of course, we set up the goal. As I said, our standard processing was about 10 hours, 8-10 hours, and we set a goal that we want to reduce this processing time to 15 minutes. So what do you think? It's optimistic, maybe unreal? And how I estimated it, maybe it was just a guess. Well, I will answer this too, but also a little bit later. So we started from night processes performance. We wanted to know on what depends our processing time. So why it is so slow and slowing down still. What we expected to see was this blue line. So we expected that our processing time depends on business data, so on our clients. But surprisingly, we've seen this red line. So our processing time wasn't dependent on business data. Despite the lack of business data growth, our processing time increased, and not linearly, but exponentially. So it was, it meant that it would be worse only with time. We couldn't do anything. So that was very bad news. We had to do more investigation. And we found out what is the problem. Where is the problem? It turned out that the processing time depended on the number of events. So not on business data, but it is in correlation with events. And as I said, event tables are one of the biggest tables and fastest growing in the system. So very bad news, very bad information. But the good information was that we knew what we had to do. We had to just get rid of this correlation and make the processing time depend only with our main data. But how to do this? Started from the requirement analysis, and we asked the question when to charge the end of the month fee. Maybe at the end of the month, based on the name, but noticed that during the night processing, these processes were huge, and but during the day, our system was not overloaded. So we thought that, well, process less is better and faster. So maybe there's a chance, maybe there's a way to offload the overnight processing and move some to process them during the day, or if this the month processing, maybe you can spread this processing through the whole month. So the answer we found in requirements and process design. For example, we have a requirement which says that we have to calc fee based on the, for example, phone call. You have mobile phone system, and some of the phone calls are free of charge and some are paid. So we have to check those phone calls, and if the number is paid, we have to calculate the fee at the end of the month. So this is our requirement. As a result, we have to query events table at the end of the month. So we had to query all 30 million of phone calls at the end of the month processing and check everyone and check if we have to calc fee or not. And if yes, calc the fee and save it to the database. But what we did was to move this processing and spread it through day and every day of the month. And we try to calc this fee and run this process to calc this fee. At the moment, we load the information about the event, in this case, phone call. And at this moment of loading, we try to calc the fee. And if the fee should be calced, we save it to the database. But, well, requirements told us that we have to charge this fee at the end of the month. So what to do? We add another column in the table. So we had 2 dates in this fee table. One was inserted date, for example, the 5th of the month, 5th of the March. And we set the, for example, charge date. And we set this date 31st of the March. So it told, and thanks to those dates, we knew that this fee should be charged at the end of the month. So we moved every processes based on the events, and every process based on the events we perform at the moment of loading this information to the database. So this was the first step of optimization, process less, and we spread everything over the entire day and month, move it from the night processes. and we processed events not at the end of the month, end of the day processes, but at the moment, at the time of the event, and the moment we load this event to the table. We set appropriate dates, some calculation fields, some sums and counters, everything needed for night processes, because, for example, we wanted not knew how many phone calls the client did from the beginning of the month, or how many card transaction he did from the beginning of the month and on what amount. And we set so those calculation things, summary, counters, etc., and updated them at the moment we load the events to the system. What was very important, those calculation fields were at the business data level, not at the event level, because we didn't want to have another big, huge table one-to-one to events, but we wanted to have this information at the client's level. So if we query the clients, we at the same moment knew everything what happened for this client, what action he did from the beginning of the month or from the year, or everything we need for night processes. The main idea was do not touch, do not query, do not update, do not delete the events table except the moment of loading the information to the system, or of course reports, because if you want to create some reports based on the events, there's not possible to not query the events table. But if for processing processes, in processes, we didn't want to touch query event types anymore. So based on those assumptions, we redesigned our structures and processes and add those types, columns and fields to our system. And then we started the most fun part of this project, code refactoring. And we also had some questions. I think I like questions. What is faster, full scan or index scan? An idea? Of course, it depends on what we want to get from the system. Index scan is the fastest if you want to ask for some specific data, for example, about the client. But when we realize that we have to process all our clients, all our main data during the night processes, it becomes obvious that the full scan will be faster, because what we wanted to do was to take all our clients, our main data, and process them instead of querying one client in a loop and another and another. We wanted to take them at once. So how many queries we need to do this? I think if we want to take all our clients at once, so we need only one query. That's right. So based on those answers, we prepared some processing schemes. So how we want our process looks like. Of course, we need some configuration also, but again, we need for all 20 processes we do during the night. We will use all our configuration, maybe not in one process, maybe not in two, but as we see our processing as a whole, eventually we will use all our configurations. So at the beginning, first step of our process, new process, was to take every configuration from our system and load them to global collections, so arrays or so. Second step was to take all our clients or our main data at once and also load this to data collections. using bulk collect at limit, of course, because we should take care about our memory. And as I say that this main data SQL was huge or big, it's only from the volume of data we retrieve from database, but the SQL statement was very, very simple because we had only 5 table joins and maybe a condition like client is active or so, because we didn't prepare those data or convert or transfer data for the specific process, because we wanted to have those data for all 20 processes. So we weren't able to prepare it. We decided that every process from this 20 will get some rare data and do whatever they need to do without querying main data again. Then we started processes 1, 2, 3, 4, 20. And what was the most important here was that only PL/SQL here was allowed. No SQL, no queries at all. And if we needed in some process some configuration, we could take it from collections. If we needed some data or add some new data, change data, we did it using no copy option because we take care about memory. And this is it. And at the end, so after we finish the 20th process, this is the moment for DML, so saving the data, update, insert, maybe delete, of course, using for all to make it faster. So how many queries do we need to close a day or close the month? How many queries do we need to perform 20 separate different processes? Well, one main data and one SQL for every configuration tab we have in our system. And what is worth to notice, it's not also only SQL as statement, but also what I mean is SQL execution. So these SQLs were performed only once in whole night processing. And yeah, as you remember, the system has had 100,000 line of codes, and only, if I remember correctly, we had about 15, maybe 20 SQLs for configuration, one main data SQL. So during whole night, we executed about 20 queries, not more. But how it would look like one SQL for 100,000 lines of codes, maybe code, it sounds maybe insane, but what I want to do now is show you how it could look like. So for a demo, I will use the HR schema. It's a sample schema in Oracle, and I will use employee table. It will be my main data, employees data, main data, and jobs table. It will be my configuration table. What I want to do is to give employees a rise, except the 10th department, because maybe I don't like them. And in the jobs table, I added new column, rise PCT, and it will tell me how high the rise should be for specific job ID. So for example, president will get 45% of rise, managers 10%, and programmers 15%. Okay. I have here EMP table also because I don't want to change the employees table. So this is the copy of my employees table. So this is my data. Okay, so we have our employees and the new column salary new, and this I want to calc. So let's see how a standard process could look like, typical process could look like. Please do not focus on the code itself, but on idea, how it could look like, how we could change it into the new approach, because I'm sure that you could do this procedure better. I try to do this as bad as possible. So, but I bet in most system you will find something like that, that you have loop in a loop in a loop in a loop, and it's not bad, but it depends on what you want to achieve. So back to our example, what we want to do is to give the rise for our employees except the 10th department. So first we have a loop for departments, and we want to exclude the 10 department. Then for every department ID, we need some employees and we iterate this data rows, and for every employee, we calc rise, we run the procedure to calc rise. How our calc rise look like? It's simple. Our in parameter is employee ID. We need some more data to calc new salary, so we need old salary and job ID to retrieve configuration. So select for employee to get a little bit more data, select for configuration to get configuration, our rise PCT parameter. Now we can calc new salary and update the data to the system, to the table. Okay, but how we could change it in a new standard approach? As I say, we load configuration to the global collection. So I have here some for this. Type jobs, jobs row types, indexed by varchar, and we have also collection for our main data. I use it here also row type. We have to change our process also. So first step is to load our configuration. Let's jump in, and here we load all configuration from jobs to our job collection. I don't use here book collect because I want to have index, global collection index as a job ID to make it easy to get this configuration from the collection. So first step is to load our configuration. Another step is to get our main data. So I join two main tables, departments and EMP, and I use book collect. I don't use here limit clause because I want to have this code as clear as possible, and limit is a little bit messy. But of course, in the real production system, it's obvious that we have to use the limit clause too. And then we have our main data in the collection, and we iterate through collection. And for every row, we run the function calc rise. Let's see it. Calc rise, our in parameter is employee row type. And we can easily get our parameter, configuration parameter, from the job collection, and the index is job ID, and calc our salary and return new salary. What is important, we have here no queries. Back to main procedure, and if we calc salaries for every employee, we can update our data here using for all. So what it gives me, let's see. I have here some tests, maybe drop data, create new data, and some statistics. And let's run it. Oh. Okay, in the old approach, we have 15,000 SQLs execution and 5,000 updates. As processing time almost 2 seconds. In the new approach, we have only 2 SQLs executions and only 1 update and almost 0 processing time. So what if we add new process here? What change? So I add new column. What I want to do is add calc some Christmas bonus. Update. Okay, so now we have new configuration here, Christmas bonus PCT. How our processes will change. I added new procedure here, and here we have also new procedure. In our loop, I added new procedure to calc new Christmas bonus, and the procedure looks like this. We have EMP ID as a parameter. We need some more data. We need to get some configuration, calc bonus, and update data. How will change our new approach? We don't need another collection because this new parameter is in a job table. We just add new function. And here, load jobs. No changes here because we already have all fields from jobs. Just in the loop, I added new Christmas bonus function. This is the function. In a parameter is employee row type. So I can get the bonus PCT from global collection and easily calc the salary bonus and return the bonus. At the end, I can update EMP table based on the collection, and this is it. How it affects my tests. Let's see. Maybe new data. Okay. So let's start. Okay. In old process with 2 procedures, we have 26,000 of SQL execution and 10,000 of updates, almost 4 seconds of processing time. New approach, we have only 2 SQL executions and only 1 update, and processing time is almost 0, almost same as the previous one in the processing with only 1 procedure. So have you ever checked how many SQL execution do you have in your system when you have some processings? It's worth to see. So this is the demo because I think we ran out of time. Okay, so to sum up, what we did during our engineering process. First, we decided to process less and to correlate our processing time not with events, which is the biggest table in our system, but with business data. We process all events at the time of loading those events to the table and spread processing over the day and month instead of querying events at the end of the day processing or end of the month processing. We did it at the moment of loading. From the code refactoring point of view, we reduced the number of SQL's execution and at the same time context switching. So we had only one SQL statement and execution during this processing per configuration table, and only one main data SQL. We use full scan, of course. We use bulk collect limit and for all, and what was the most important, our procedures and functions were only PL/SQL code. There were only PL/SQL code, no SQL were allowed. It wasn't easy to get rid of those all queries from the code. Believe me, sometimes I spent hours to come up how I can get rid of specific SQL, how maybe I could add some additional fields in the table or something. It was a really difficult job, but we did it. And results, if we manage to reach this 15 minutes of processing time, yes, we reduce processing time from hours to 15 minutes. And maybe now it's time to explain how I estimated this 15 minutes. I assume that the longest part is retrieving data and saving data. So I prepared the test procedure and I prepared the cursor and get all main data, iterate in a loop, set some random data, and at the end I did update using for all and measure the time, and it was 8 to 10 minutes. Maybe I add 50% just for other stuff, and yeah, it was this 50 minutes, and I was right. We had, thanks to that, we had unit tests for the entire system, because believe me, if you do not have SQL in your functional procedures and function, it's very, very easy to test this, because you just put some in parameters and check the output. So it's very easy to test it. Thanks to that, we have very few errors and we have low cost of system modification and development. We reduce development time for even small feature from weeks to 3 weeks to 2-3 hours even. Thanks to that, we have low maintenance costs and we were on time and budget. Thanks to that we were prepared, we had the plan, we have standards, best practices, and we had unit tests. But of course, always there are some disadvantages, and we had one, but very, very big disadvantage. And this was boredom. New system was boring as hell. Really, nothing happened. It was just running every end of the day, end of the month processing, finished within a couple of minutes, 15 minutes, maybe 10 to 20 minutes. No errors, no issue, no performance issue. So if some error occurred in the system, we as a team jump on it and try screaming, "This is mine, I will fix it," because we want to do something interesting. And if you want to be performance hero and try different techniques to tune SQLs, this approach is not for you, because there is nothing to tune anymore. No SQL, nothing to tune. Well, so this is all I wanted to tell you, to share with you. So if you have any question, it's time to ask, or you can reach me via email, Twitter, or blog. Maybe I check if. So yeah, thank you very much. There are any questions, maybe?
If you have any questions, please go ahead and submit them. And while you do that, thank you so much, Monica, for that presentation. We are just so happy to have you here, and we're going to have you back again, I believe, at the end of the month. Yep, so if you guys loved this presentation by Monica, please go to NYOUG.org, find the sign up link for her. I think it's like May 31st or so, somewhere that last week of May. and a Tuesday already again. Phyllis, yes, the slides will be available. We'll ask Monica for them and we will share them with you all. So look for that email from Katie Barnes, either end of day today or sometime tomorrow. She should be able to get you guys everything. Any other questions? All right, well, if there is nothing else, if you think of something later, feel free to email Katie back the question and we can share it with Monica, or as Monica said, follow her on social media. You can maybe share your handles with us too, and we'll share them back out. All right, thank you so much. Thanks, Coleman. Thanks, NYOUG. Monica, thanks. We'll see you again soon.
Thank you. See you later.
Bye, Monica. Thank you again.